Today we're going to talk about equations with fractional coefficients. What that means is it sounds kind of hard, but basically it's equations with coefficients that are going to be what? Fractions. That's all it means. Okay. So whenever you have equations with coefficient of these equations, right, being fractions, all we have to do is just like what we did last time. How do we get rid of all these denominators of this equation? What was the nice thing that we could do? Yes, sir? No, that only works if you have a fraction equals another fraction, right? If you have a proportion, that's the only time it works, okay? But this time, you're not going to have just fraction equals another fraction. You're going to have like two fractions, maybe adding two fractions, sum of two fractions equal to another one. So how do we get rid of all the denominators? No one remembers? How did we get rid of the denominators yesterday, really? What? Thank you. So we multiply both sides by the what? LCD. That's the key step. Okay, so write this down. So every time you have an equation with fractions, this is going to really help you a lot. All you have to do is multiply both sides by the LCD, and it just makes it so much easier. You get an equation without any fractions then, which is really easy because we know how to solve those equations, right? Easily. So that's the key idea. Again, like last time, we're going to be multiplying both sides by the LCD. So please remember, whenever you have equations with fractions, just multiply both sides of the equation by LCD, and it just makes it so much easier. We'll show you in a minute, okay? So let's take a look at example 1 here. As you can see, we have n over 3 plus n over 4 equals to 7. Now, is this equation similar to what we had yesterday? No. Last time we had a fraction equal to another fraction, right? That's when we did the cross multiplication, right? Do you guys remember that? But that's really multiplying both sides by the LCD. You guys remember? So guess what? This time you cannot do cross multiplication, but we have the denominators of 3 and 4. What is the LCD of 3 and 4, class? 12. And so we want to get rid of all these denominators. So we're going to simply multiply both sides of this equation by 12. Yeah. Look what happens when you do this. Of course, you're going to multiply the whole left side, right? Both of the terms. So you must distribute. Look what happens if you distribute 12 to n over 3 and n over 4. What would happen to all the denominators, guys? They go away. They're gonna cancel out. How many times does 3 go into 12? 4. How many times does 4 go into 12? 3. Do you see how it simply becomes? I even wrote it out, and I showed you how I canceled these out. Do you see how it simply becomes 4n plus 3n equals 84? Isn't this nice? Okay. We're not done. We're not done, obviously. But isn't this nice? Look, we had an equation with denominators, right? This equation is now simply 4n plus 3n equals 84. We were able to rewrite this, right? By multiplying both sides by the LCD, we got rid of all those denominators. Much easier to solve, right? Look what happened. Look it carefully. I'll give you time. Look at it. So, okay, take a look at Claire side. I didn't put any box. Are you happy? Yeah, we're not done. You're right. When I'm done, I should put a box or a circle. So I just highlighted it because I just want you to see how this original equation became so much easier. Now we don't have any denominators. And do you know how to solve this equation? Yeah. What is 4n plus 3n, class? 7n. And all you have to do is divide both sides by 7. And as you can see, it's much simpler to solve. Okay? So there's the answer. Thank you. There's the answer. N equals to 12. Okay?
Yes.
So the question is, can we look at on the left side? We did this before. Could we just add the, thank you. Could we just add those two denominators, having a common denominator, right, 12, and add them together and then multiply both sides by 12 and so forth? The answer is yes. But turns out when you have an equation, it's much easier to just multiply both sides by the LCD. Of course you could do that, right? That's fine. But when you had an expression, let's say I just had this only on the left side like this, n plus 3 over n plus 4. And if I ask you to simplify, that's the only thing you could have done, right? Making it into a common denominator, add them together. But now that we have an equation, of course you could do that, but isn't this a lot easier? All you have to, because we have left side equals to another right side, just multiply both sides by the LCD. The equation simply becomes, right? You could always rewrite, these equations are equivalent. You could just rewrite this as 4n plus 3n equals 84 without any denominators. That's the nicest way. Of course you could do that, but it'll take you it'll be a little bit longer when you do that. So that's a good question. Does that make sense? So yes, you can simplify the left side, you know, add them together with common denominators and so forth, but you don't need to do it that way. It's much easier to just get rid of the denominators since we have an equation, right? If you just had an expression, right, you had no choice. Okay? All right, let's move on to the next one then. Here's example 2. It says y minus 1 whole over 3 minus y plus 1 all over 5 equals to 2. Again, like Tajwar suggested, we could actually, you know, simplify the left side by having, you know, making them have a common denominator and so forth, add them together. But we have an equation. Since we have an equation, we could, remember, what property tells you that you can multiply both sides by the same number and would not change the answer? Multiplication property of equality, right? That tells us that we can multiply both sides by the same number. It will not, right, change our answer, right? The equations will be equivalent. So all we have to do is what, guys? How do I get rid of these denominators 3 and 5 so that it'll be easier to solve? Multiply both sides by 15. Okay, go ahead, everybody try. I'll wait. See what you get. As we said before, we're going to multiply both sides by 15, and of course, I'm going to show my work. I'm going to put parentheses around this whole thing. I changed some of them to addition. Look what happens when I multiply 15 times y plus y minus 1 over 3. What would happen to 15 and 3? 15 is really 15 over 1, isn't that right? Does 3 go into 15?
Yes.
How many times does it go in? 5 times. So you have to do 5 times in parentheses y minus 1, right? Does that make sense?
Yeah.
What about 15 and 5? How many times does 5 go into 15?
3.
Okay. So then we get this. I actually wrote this out for you so that you can see how 15 over 3 becomes 5. Negative 15 over 5 becomes 3. Okay. So, and then of course, what do we have to do with these numbers in front of these two binomials? You have to distribute. Does that make sense? Okay, so when we do this, what do we get here? Matthew, tell me what I write. Oh, Matthew's not here, sorry. Royce, tell me what I write.
5y minus 5.
Right?
Minus 3y.
Mm-hmm.
Minus 3.
Good. Equals to, of course, 2 times 15. Don't forget to multiply, right? Right side by 15. If you multiply left side by 15, you got to multiply right side by 15. And of course, could we simplify and solve now? Does this make sense? Okay, go ahead, everybody finish up. I'll wait, okay? All right, so most of you are done. So when you distribute, we get this. What do we get on the left side here? Bella, when you simplify the left side, what do we get?
2y minus 8.
Equals to?
30.
Good. And of course, you add both sides by 8. Thank you. And you divide both sides by 2. How many people got? 19. That's the answer. Very good. And I wrote, you could put them into the set notation or just write y equals 19. They're the same. Okay, let's move. Any questions? Pretty easy. Do you see what to do for these? So every time you see an equation, right, where they have fractions, just simply multiply both sides by the LCD. It just makes it so much easier. You see how it does that? Okay. All right, let's move on to the next example. Here's example 3. 2y minus y over 2 equals to y over 3 minus 7. This time, you have 2 fractions on the left and 2 fractions on the right. It's not really a fraction, but 2y, you could think of it as a fraction, 2y over 1. You have 2 terms on the left, 2 terms on the right. Again, same exact thing that we've been doing. Guess what we're going to do here? How about Eunice? What do you think? What should we do to both sides of this equation? Yeah, multiply both sides by 6. Where did you get 6? Eunice? LCD of 2 and 3. Exactly. Does that make sense? Go ahead, everybody try. Of course, when you multiply the whole left side, how many terms do you have? Class, how many terms do you have on the left side? 2. So are you going to distribute it? Yeah. What about on the right side?
2.
Yeah, same way, okay? You have to distribute. Every time you have more than one term, you got to distribute, okay? Go ahead, everybody try. That's a good question. You just look at the denominators of every term. It doesn't matter which side it's on, right? You don't have to, right? It could be on the left side or right side, doesn't matter. Just look at all the denominators of, right, every term and then find the LCD, okay, of those denominators, and it'll work out because we want to cancel out all the denominators with the LCD. Doesn't that make sense? No matter whether it's on the left side or right side. Okay. All right, so when you multiply both sides by 6, how about
I got that.
Carolyn, what do we get on the left side when you do this?
When you multiply by 6,
The left side becomes?
12y minus 6y over 2.
Are you sure it becomes 12y minus 6y? Because you have to multiply 6 times y over 2.
Yeah,
Doesn't the 2
6y
cancel out?
over 2.
Oh, it's over 2. So what's 6y over 2? That's simply 3. Okay, good. What about on the right side? Sorry, I didn't hear the last part.
6y
Uh-huh.
over 3 minus 42.
Good. And so that still work. And when you simplify, it becomes simply,
2y
yeah,
minus
very good. So we get 12y minus 3y equals to 2y minus 42. You see how, look at the first equation, right? Isn't this a lot simpler? You don't have any denominators. We know how to solve simple equations like this. Right, guys? Go ahead, everybody try. Finish up. I'm sure most of you are almost done. Okay. So when we solve this equation, what do we get here? Jason, what does the left side become? 9y equals to 2y minus 42. And of course, subtract 2y from both sides, right, guys? We get.
Whoa, hey.
Wait, what happened?
I got negative 2 though.
You got negative 2y on the right side?
Oh, never mind, I see it.
Okay, so you should have gotten 2y minus 42 on the right side, right?
Wait, what's happening here?
Okay, take a look at what we have. The answer should be negative 6. Look, didn't we multiply both sides by 6, right? And so didn't we get 12y minus 3y equals to 2y minus 42?
I see.
Do you see a mistake? Okay, then of course, you divide both sides by 7. The answer is negative 6. Okay, if you didn't get it right, go ahead and fix it. How many people got it right? Raise your hand. Okay, good, most of you. If you didn't, go ahead and fix it, okay?
I did.
You should have all gotten negative 6, okay? Let's take a look at example 4. I like to give this one because whenever there's a 0 on the left side, people seem to do some interesting thing that is not so correct, okay? Didn't get it wrong. So here, I got 0 equals to 4n minus 4n plus 5 all over 6. What are we, this time the LCD is really easy to find. What's the LCD for this?
6.
Yeah, okay, so we're going to multiply both sides by 6, right? Now, do I have to multiply the left side by 6 also where 0 is? Yeah, what's 0 times 6?
0.
Okay, please, 0 is a number. Can I not write nothing? Can I just write nothing there?
No.
No, because if you do, then it becomes an expression, right? Equation doesn't become an expression. Okay, equation is always an equation, right? So, yes, please make sure you put 0 on the left side. And of course, when you distribute 6, how many terms do you have on the right side? How many terms do we have? Mainly 2, right? 4n and negative of this fraction, correct? So you got to distribute to both of these terms, correct? Right, guys? Go ahead, everybody try. See what you get. I'll wait. All right, we're going to multiply both sides by 6, as we said. And when we do, did you all remember to distribute the 6 to both of the terms?
Yes.
Okay, somebody tell me what to write next. How about, let me call somebody random. How about, Song, what do I get? On the left side, I get, of course, 0. I get 0, not 6. Be careful. Yeah, 0 times anything is 0. Okay, then on the right side, what does that become? 4n times 6, you get, good, 24n. I just changed the addition, right? Plus negative of this. So 6 times, well, what happens to 6 and then the 6 on the bottom?
Cancel.
So what do I get? I get 24n plus what? Negative 24n? So 6 times 4n, I get 24n, right? Right, plus what? Now you gotta multiply 6 with this term right here. But 6 is cancelled out. We simply get 24n minus. Oh, are you multiplying 6 with 4n and 5? But we have 6 on the denominator, right? The 6 they cancel out. So guess what? We just simply get 24n plus exactly negative 4n minus 5. Isn't that right, guys? Right? Look, I even wrote it out, and we knew that the LCD was 6. That was obvious. So you see how the 6 cancel out? You don't write 24n here. They cancel out, so you just simply get 24n plus negative times 4n minus 5, and of course you could distribute that. You get, just like Song said, you get 24n minus 4n minus 5. How many forgot that? On the right side. Very good. And of course, what do we do next here? Livy?
Well, you would subtract 4n from 24.
Right, you would simplify the right side, which you would get as what?
20n minus 5 equals 0.
Yeah. And of course, you add 5 to both sides. How many people got, and then divide both sides by 20, how many people got 1/4? That's the answer. Very good. Did anybody put down 4 as the answer? I see that a lot. People, they just see 20 and 5, and they see 5, and 20, they just write 4. Well, you got 5 on the numerator. The answer is not 4, it's 1/4. Correct? So please don't do that. Okay, So a lot of you got it right. If you didn't, go ahead and fix it, and you can, of course, ask your group. Go ahead, guys. I'll give you some time. So, this one was kind of interesting, though. Look at the very original expression. I have it right here. Equation. Guys, take a look at this. Turns out there's a second method of doing this. You know how we have 0 equals to 4n minus 4n plus 5 over 6? Did anybody see how you could have done this, sort of doing it the way that we did yesterday? Where how we could rewrite this as Eugene? How?
Move one of the variables into the other side.
Exactly. If you were to add 4n plus 5 over 6, guess what we get here, guys? We get what? Could we do that? Could we add both sides by 4n plus 5 over 6?
Whoa.
Did anybody see this? If you did this, what do you get? You get a fraction equals to another fraction. Yeah, we could have cross multiplied. But if you didn't see it, it's fine. But you see, you could have done it that way. If it equals to 0, right, you can move one of the term on the other side. You get a fraction equal to another fraction, right? Don't we get a proportion, right? Then you could have just done the cross multiplication. Still get the same answer, but it's a bit easier. But if you didn't see it, it's fine. Okay, so I just want to show you, right? The general way of doing it is every time you see a fraction, an equation, guess what? Multiply both sides by the LCD. Okay, does that make sense? Right, sometimes you could use these shortcuts, but you don't have to do that. It's the same sort of work, okay? Let's move on to the next example. So here comes your favorite part of the section, the word problem, okay? So here you go. Write this down, but it's really simple. Write this down. 1/3 of a number is 4 more than 1/5 of the number. Find the number is the question. And since we're talking about equations with fractions, what sort of equation do you expect to get when you do word problems in this section, guys? Equations with fractions. Oh, it's a coefficient, right? All right, so we got, and as you can see, you'll see that in a minute. 1/3 of a number is 4 more than 1/5 of the number. Find the number. So write this down. I'll wait. And think about how many unknowns we have and declare your variable, okay? Go ahead, everybody try. And if you can, write down the equation too. That'd be nice if you can do that. Here we go. Let me ask, okay, first of all, class, how many unknowns do we have? Show me with your finger. How many unknowns do you have? Some of you say 2, some of you say 1. There are 3 unknowns, you think? Really? There are only 1 unknown, guys. There's only 1 unknown because all they want is the number. What are the other unknowns, you think? Some of you said there were 2. Yeah, but 1/3 of a number is not unknown. We know how to figure that out.
Well, I know, but you don't know the third of the number.
Okay, but if you know the number, you can figure that out. You know what I mean? But
Yes.
so okay, here. So there, do you agree then? There's only 1 unknown, guys.
I got
Are we good? So there is 1 unknown in this case, the number. Now, let's look at the first part of this sentence. What does it mean when they say, Claire, 1/3 of a number is? Let's just translate that. How would you translate that into an equation?
You would write 1/3
Uh-huh.
and then x.
Right. And what does is mean?
Equal.
Okay, a lot of you helping you out. Yes. Remember, is means equal to, okay, yes. So it means equal in terms of when you're translating into an equation, right? So thank you. So there's 1/3 times x equal, right? That's what it is right here. That's the first line. So we have the first line translated. What does 4 more than? Okay, so when we say 4 more than, is it 4 plus something or is it something plus 4? Something plus 4. You guys remember more than or less than? You got to switch the order around. So what is it? What is that something? Well, something is 1/5 of the number. Who could tell me how to write the rest? Spencer is not is here. Go ahead. Spencer, what do I write on the right side? Plus 4 is correct. So it is simply 1/5 of a number. Isn't that 1/5 times x? Plus 4, because it said 4 more than that, right? Are we good? How many people got this equation? Raise your hand. Very good. If you got this equation, then you should all be able to solve this without much problem. Okay? Anybody need more time to solve? I think most of you are done already. Okay, so then, okay, hold on. What do we do here? Dana, what should I do to both sides of this equation? Multiply both sides by the LCD of 3 and 5, which is 15. So here we go. Did you all do this? LCD multiply both sides by 15?
Yes.
Yes, and then there are 2 terms on the right side, so you got to distribute that. Don't just multiply it to 4. That'll be wrong. Okay, so then Samuel in the back, what do you think? What should we write here? It becomes.
Oh, okay.
So all the denominators should go away. What?
On the right, left. It's
On the left.
5n,
5x or n. Yeah.
and on the right is 60. Yeah, 60 plus 3x. Or
Oh, so remember you got to write plus 4 later, right? So
3x plus.
correct. Does that make sense? Remember, Samuel, when you have more than or less than, you got to switch the order around. So it's something plus 4, not 4 plus nothing. For addition, it doesn't really matter, but for subtraction, it does. So, how many people got this? Is this easy? Okay, so what do we do next here? Of course, we subtract 3 from both sides. How many people got 30 as the answer?
I did.
Very good. So, did you write as a sentence?
Yes.
Okay, very good.
No.
Okay, you're supposed to write as a sentence whenever you have a word found. You're not done, Claire? But do you understand how to? You got it? Okay. Are we good?
Yes.
All right,
That
good.
was
Here's something that you should be careful of. Let's say that I have this. Could we cancel out 5 and 25 right here?
No. No, it's not about to
Could we do cross cancel? No, you cannot. When can you cross cancel only? When is what? Yeah, if this was, so guys, listen. When you had this as a multiplication, then you could cross cancel, right?
Yes.
So in other words, if I have 25x over 6 times 7 over 5, then yes, you could rewrite this as 25 over 5 times 7 over 6 times, right, x over 1. Could you not? Then this becomes, right, you could cancel those out.
Wait,
But can I do it on this? Can I do 5 and 25 here? No, if you have addition, you cannot cross cancel. Please be careful, right? Because cross canceling means you're dividing top and bottom by that same number, correct? You cannot do that for this. Please be careful. Yes? All right. Good.